Welcome to this week's speaker series. You all know that these talks are sponsored by the Data Institute, the umbrella organization for all data science and data engineering programming and research here at the university. To our outside guests, thank you so much for joining us today. To our students, we appreciate you all day, every day, so thank you for being here. Excited about today's talk. We are hosting Richard Meng. He is the founder of ROE AI, backed by Google AI Ventures, and former tech lead at Snowflake Gen AI, where he helped develop Snowflake Copilot and a state-of-the-art text-to-SQL model. Previously, he led LinkedIn Skills Knowledge Graph integration. As AI transforms data science, LLMs and AI-powered BI analysts are reshaping how we extract insights. Sorry, I'm not doing well today. I've done better introductions, but just know that we really appreciate you and are so glad you're here. But Richard, more importantly, is going to share his journey of building AI-driven solutions, the impact of LLMs on data teams, and the future of AI in business intelligence. All of that to say, well said, poorly said. Welcome, Richard. Thank you so much for joining.
Thank you. Can you hear me clearly? Let's get started. So I'm Richard, founder and CEO of a small startup called Row AI. So when Shan introduced me to this course, I'm both excited and afraid because I know some of you are in the crossroad of choosing a data career. So I'm going to be very cautious about actually talking about what I'm going to say to you today. And the agenda for the topic for this talk is mostly just sharing what we've seen in the unstructured, especially the unstructured data. I know most of you have taken the course about how to actually boost, how to run a linear regression model, basic introduction to NLPs, and maybe some of the network stuff. So today I'm not gonna talk about that, but mostly gonna talk about how do you work with what the use cases for files, documents, PDF websites, and share some of our work in how to solve that with data languages. So to get started, I think it's great to share with you like what this industry has been saying about what is the trend we're going right now. If you have talked to investors, but to leaders in the company, there might be some rumors going on. Be like, are we going to hire any more data analysts? If we already have a tool to convert text to SQL, can find the data. And at the same time, many BI, business intelligence analysts and data analysts are complaining about how boring the job is. I'm at Snowflake, and even at Snowflake, I have data scientist friends that are complaining about how tedious their jobs are at Snowflake. Right? Can't believe that. The truth is that it's probably true, right? The AI is acing the boring tasks. That's including writing SQL. Truly boring. No one wants to write SQL if they get to insight for a second. Integrating with dashboards, doing data engineering pipeline, truly boring. Data quality debugging, right? Why one of like 100,000 of your 10,000 rows are like empty, right? You gotta figure out where the downstream processes are. But I think at the same time we should be happy. I mean, as data professionals, we shouldn't be. It's always the time to invest in our life into this mundane tasks. To be 100x efficiency. Because that's the reason I'm giving this talk here. We think that AI also creates 100x more creative and valuable data tasks to data analysts. So that's a good segue into the unstructured data analytics and what my LLMs talk. And multimodal analysis, actually. So I'm going to share roughly about like 3 intuitions and 3 paradigms that you probably have or have seen on the internet. But it's just good to set the stage first. I think everyone, raise your hand if you haven't used ChatGPT yet previously. Great, yeah. So anyone has used LLM inside your data tool of anymore? Either text to SQL or like use some kind of AI unit, UDM. Okay, now not a few hands. I think the temperature.
Please put the mic by your lips.
You can hear me now?
Yes.
Okay, sorry about that. Yeah. So the first intuition is LLM has the word knowledge. How do you interpret that? And I'm going to tell like why this is important later. But if you ask ChatGPT like a question or paste in the image of University of San Francisco here, what like just ask what is this? It will tell you a blurb like this is the logo of the school and give some information, and you can maybe ask them follow-up questions like is private school or public school, is it close to UCLA? How many sub schools within the University of San Francisco? This is quite important because the LLMs we're using has pre-trained on all of the information that's related to this entity. So that means if we're asked a question about what does Apple sell, or just basically looking at one of the public financial filings from the internet, and we just ask, what does this filing tell us about? It immediately knows your question and starts to give you some answers. The second intuition is there are 2 different concepts when using the AI. You've seen many chatbots today, and the chatbots are usually coming with the vectors, coming with embeddings. Are you guys familiar with that, right? Yeah. And of course, at the end, generate the answers with the LLMs. The intuition, second intuition here is when building this kind of applications, is we have to understand the difference between the LLMs and embeddings. The LLM captures more information than embeddings. That's the one liner. So if you ask a question about showing a milk and showing a meat state, right, and ask questions like which is non-dairy, large language model embedding will choose the left. If you look at use one of the playground, use OpenAI's largest embedding model. Very counterintuitively, you can embed that sentence. You can embed the just word milk and embed the word meat. The surprising fact you will find that milk is actually more closer to the question, even if it's asked about non-dairy than meat. But large language model will choose the right. This is because embedding model converts a natural language into a 2000 length vectors. But large language model does not do that conversion, so it keeps the original information intact. This is very foundational when building this application, because usually in the data engineering we encounter I think many of you in the future might encounter the chatbot. People complain about chatbot quality. What they don't realize is that when they do this step, data engineering steps to convert the documents into this vectors, a lot of information is already lost. This is one matrix to illustrate the difference. So you can use any playground today to try this. You just type non-dairy products, type cheese, type milk, type meat. You will find that non-dairy products is more relevant to milk and cheese and meat. Very counterintuitive. The intuition 3 is that large language model is a generic unstructured data processor. And that segues, what I mean is that you don't need to, well, let's take it back. Imagine you're going to be a data engineer, work on the documents related tasks. For example, extracting data from an invoice, very simplest task. Usually, you will have to leverage one of the document processors on AWS or Google Cloud and run it through. But today, you don't need to use them. You can use a generic large language model today to extract any information from any documents. Just convert them to pages, and work as like natively. You can pass in like any images about an animal and ask what's in there, or any images just showed as a USF's logo and ask like what's in there. Applies to any case out of the box. Of course, this excludes some of the private domain use cases such as in a medical and manufacturing, there might be undersampled data during the pre-training phase, and but those are usually you have the domain specific models to tackle those cases. But for general like world data in financial insurances, if you're encountering any documents, LLM should be a very generic data processors to understand those unstructured data. Now I'm gonna we have set up the stage for the 3 iterations. I'm going to share 3 paradigms, data engineering paradigms when working with the unstructured data. First paradigm is simplest one, converting the unstructured data to structured facts. This might be too small for you to look at, but on the left-hand side is state minimum wages pulled from the government website. If you're working for ADP, this is one of the data that they need to extract from. They've been spending a ton of resources to work with these government forms in the past. Usually deploy like a team of engineers to maintain data quality. And this is actually pretty complex. If you look at like how the form is structured, it's too small. You see it again, make it bigger. Yeah, go down. Yeah. So if you don't see this box of fill, this basically inheriting the top row, but it's empty. So how do you make it work if you don't have LLM? You have to create lots of rules to say like if the first line is Faro and the second line is like Alaska, but it's empty, inherit the Faro. First, it will work, right? But if you have a large vision model, if you build this into a GPT-4, converts entire web page into an image, one line code, and send this to GPT, any commercial large vision model, and you just give some prompt. Like if you see empty rows, it's probably inheriting the top rows and the top of data. So and you will get a pretty beautiful structured table like this. Just one line of query and one line prompt. Really powerful. Simplify a lot of data engineering steps. And the more complexity, right? This is Connecticut. Connecticut has a subcategory, right? Has 2. Where is it? Hotel, restaurant, and bartender. They have separate minimum wages, and AI will be smartly enough to know that it still belongs to Connecticut when they do data trash. Attach the right state schema there. This is just a sample. Well, you can try it out. It's public information online. I think it's a good like little bit hack exercise. So the principle, the learnings here, right, about this paradigm is that in the future where the data engineers will be working more extensively on the unstructured data like these websites, as the capability of a large vision model becomes more powerful, and usually we work with the source HTML code, the source the text representation behind the websites, convert them to text to markdown, right, and then work with them. But in to a human's perspective, right, a website is only meant to be understood after they're rendered. A better approach is not to convert them to text. Well, you can, but also convert them to a visual representation and leverage the multimodal's capability to understand the layout itself. Layout is key here. This paradigm applies to when you need to extract some information from PDF documents. Second paradigm, unstructured data to structured insights. No, it's not facts, but insights. Well, I'm just going to use a case about my startup, right? I'm hiring, software engineers and data engineers. So if you want to work with startup, come give me a resume after the talk. Just flying it. This is a resume, right? And usually when you submit a resume to an employer, you won't tell like you're working at a startup. You just tell like I work at Row, or I work at Google or Facebook, right? Something like that. Mm-hmm. But when recruiter wants to recruit you, they don't look for they may look for people who work from Facebook, but for me, I'm just looking for someone who work both at a bigger company and the startup world. I couldn't name all the startups that I know. I couldn't name all of the big companies that I know because it's just evolving, right? So in this case, like, how do you do that today? Well, if you're a data engineer want to work on this problem, you can use the large vision model. You can be like, does this resume based on this resume, does this candidate have experience in a startup or in a big company? Leverage the intuition we got. If someone worked at Facebook, the AI knows Facebook is a big company, right? And beyond that, right, we can make the AI to give us some math calculation behind the scene. Just summarize all the working experience. So at the end, your schema your data engineering is becoming very simple. You just put up a schema like B Corp YOE, give a prompt about what does it mean? What do you want to? What does this B Corp YOE means? Just someone who worked at big corp experience and summarize all the year experiences. They will get the number 3 out of that. So we skip the data extraction directly to the insights. The number 3 paradigm is unstructured data to unstructured insights. Anyone has used the deep research? Yeah, deep research. It's from OpenAI. It's a new one. It's okay. You have used it?
Yeah. Well, no ChatGPT, but Perplexity's and
Perplexity's one? What's the cheaper one?
yeah.
Cheaper. I know. I know. Even takes us some time to decide whether to expense. It's pretty expensive, $200 per month. Deep research. The reason deep research, how does deep research work is that if you're using like the 4.0, like ask it a question, it'll immediately start popping up answers. Maybe doing a web search. If you ask an O1, it will start a little bit of thinking, right, and behind the scene, and then give you the answers. If you're using a deep research, it'll start first start doing a bunch of Google like searches, as both like depth first search and breadth first search. It will try to expand as many as brand as possible. Takes like maybe 15 minutes to generate one answer. That's how it works, and that's why it's very expensive. It usually like takes millions of tokens to generate one answer, right? And the answer you will generate is going to be a 15,000 words report, and that's your insights. That is a threat, of course, to a lot of consultancy firms, which are pretty much just doing that like manual labor work for all year and charging people 100K. So deep research kind of kill the kind of lower end of consultancy firms on that front. Just to give a background. So that is what we call the unstructured insights. So typically, like we at the data development, we're not used to work with the unstructured data. We tend to convert the unstructured data to the structured data first and try to build some patterns, statistical patterns out of it. But at the end of the day, right, what we want to generate to the leadership is the unstructured work. Right? When you do the presentation, you're telling them to, okay, we should probably figure out some traces from here to there, and then we should like direct our marketing teams to do this and that. So that itself is the unstructured insights. So how can we for some of the use cases, there's no step to convert. There's no like structured step. You know what I'm saying? Because you're dealing with all the web pages, all the free format paragraphs, anyways. So, and going back to this example about hiring. Well, who should I hire at the end? If I get 10 candidates, right? That I filtered out by startup years of experience and big corp years of experience, and I have like 10 of them. Well, it turns out that I can just ask an LLM like O1, right? The better one that does a little bit of thinking behind the scene. Rank the candidates based on my criteria. Okay, I want maybe out of the candidates, I want someone who have did a little bit of GitHub or has worked in document research, etc. I couldn't map all those criteria into some data schema. It's too time consuming. But I just roughly filter out down to like 100, enough to fit into my context window. Now it's getting pretty large. I think now Gemini can fit pretty much 2 million tokens. Roughly, like if you're dealing with document or web pages, one web page or one document page, it's about 1,000 tokens. So you can fit like 2,000 pages into a one context window. But I can fit 2,000 resume and just help me rank the top 10 candidates. That's it. Right? You don't need to leverage any XGBoost linear regression here. Of course you can if you want to spend some time. But this should give you a good pass on what you should give you a good list on something you can chew on. And of course, there are fine tuning available always in the commercial vision models. You can choose your preferences, based on based on your training data. So we covered 3 paradigms here: structured facts, structured insights, the unstructured insights. So now, these are the building blocks, right? Like when you operate with data, you kind of just leverage this unstructured data. You just kind of leverage these principles to write your code, building a data pipeline. But and you have a lot of ways. Well, you can working with LangChain. You can just get rid of scrap LangChain. I'm gonna write my own library. LangChain is too fast, right? You can do anything. What are the pros and cons? So as data professionals, we want, our sole goal is to get insights as fast as possible and spend less time on wrangling with data pipelines. It turns out it's proven that throughout these decades, the best language to work with data is SQL at the end. It's a structured language. It's declarative, right? It's there's a lot of like convenient features like similarity search, right? Grouping, aggregation, memorization. With the commercial data warehouse like Snowflake, you're going to be talking to Snowflake 90% of the time, 50% of the time, and another 50 is Databricks. After targeting company, so SQL is going to be if you use SQL on those three platforms, or even BigQuery or Redshift, you typically don't need to worry about maintaining and running like control like which clusters run, etc. Just like plus the button, it will manipulate one query will manipulate hundreds, thousands of terabytes of data for you. So it's very elegant language in the last 10 years to manipulate large, infinite cloud resources to compute a large amount of structured data. So one main question is, can we operationalize SQL on the unstructured data as well? Instead of making it control the numbers or text, also make it used for controlling the documents, right? Applying for documents, applying for the images, web pages, and even videos. So I'm going to show like a few examples about how industry are already using SQL to do some of this kind of stuff. And I think it's very useful for get me of what's happening there. So if you use Databricks and Snowflake today, you may have regular docs, and there is AVI functions called the AI query or if you are working the customer service as well, customer service in retail, you might want to understand how the core reactive to your products. The way that you have the model or model. You still have to spend a lot of time to train the model, for sure. But if you just use an LLM function, you can just ask like, what's the segment of the following column, and just pass the text to that function. That's it. Generate a new column with very structured segment, and it's really better than Wordle. The work that I typically done to do it offline, like wrangling with a Python worker and do the ETL flow, but instead you just do it there on and Linux. And go a little further about unstructured data, like multimodal unstructured data. Think about you're doing competitive analysis on behalf of a pharma company, and you want to understand what other firms are doing, right? From the websites, from public domain websites, clinical trials, and there you can pretty much say like, what are the new products we launched from last year versus this year? And here's I just put it very simple, very naive representation of the query, but you can essentially feed the website as an image, visual image, into this other two parameters and do a trend analysis. Of course, it's going to be like, okay, from 2010 to 224, what has changed? Just give me a kind of analysis, right? And that's it. You just able to essentially manipulate, do this for tens of thousands of parameters to one query. Aggregation works in this context as well. You want to extract the revenue from the managed document, extract as a first step, and then use the revenue as the aggregation. I use the year as the aggregation, and summarize the revenue, expected revenue as a separate column. So all the benefits you have in SQL will transfer to unstructured data seamlessly. But there are challenges too, right? The SQL is not a syntax traditionally for the unstructured data, right? For example, for like syntax, it only works in a text way, right? It does not work for images. For example, if you're running a retail shop, if you're running a Lululemon, right? You want to find like which of advertisement are performing the best, right? Videos, images, stock photos. And you want to find like give me all the images that look like like a purple color, and just tell me and do an aggregation on the purple color images and see, compare with the blue color images and see which one performs better. The like query does not work in that case. You have to go through the step and basically build a separate like a vector database and somehow put the classification, pre-label the data first. So like query does not work for multimodal data yet. Aggregation seamlessly, work with aggregating insights from documents and images is still like very limited in the data warehouses. Like for example, you want to compare some of the pages of one document to some of the other pages of one document. You have to think about like it's very limited. It's basically not supported in any of the data warehouses today. But I think that's potential that we've seen, and right, the future of SQL is unlimited. There's with this tool and using data language, there's infinite amount of creativity you can do on the unstructured data. And I think that's what we think data professionals should spend their precious life on, extracting more insights from more diverse type of data. And with that, this is all I have today. We make a SQL workflow multimodal data with LLMs, and formatting data. I posted two links below about how to hire like data scientists and how to rigorously analyze the financial filings with SQL. And I think we have right about 30 minutes. I think we can open up for some questions.
So, going the slide which compares the LLM with the embeddings, I'm touching on that slide. The next one actually. Yeah. So over here, I'm wondering if this is a deficiency in the embedding, or is it a deficiency in the cosine similarity that you're using to do the comparison? Because it's not understanding the word non to invert. So in cosine similarity, you're finding the closest thing, but non needs to find the furthest thing. So is it really a problem with embeddings, or is it really a problem with cosine similarity?
Yeah, the question is like in embedding search, we leverage there are two components. One is converting the word to embedding vectors. The other is to compare it to embedding vectors are same or not, are close or not, how far are they or not. So the question for this example is like which is as meet closer to non-direct is more because of the deficiency of the vector or
the cosine similarity, because it's not taking into account the word non is inverting the meaning of the word dairy.
Yeah.
Right. So you should actually, if you're using cosine, you might want to go further away rather than cosine.
Yeah. I think that's a great question. I do not have a good answer to that. Yeah.
That's fair. I appreciate it.
Next, turn it on and.
Just
Right.
I'll just see that.
Yeah.
So I can project.
Yeah.
So my question, thank you for the thought, first of all. So you mentioned about using resumes, feeding them into a large language model, and having them like score the top, say, 100 candidates. But like I guess like the question that you're asking doesn't have like a deterministic answer. It's very much open to interpretation. So like what strategies have you implemented in terms of being able to like evaluate the model and see how is it performing? Since it's not like black and white, like you don't know necessarily what the answer is. Like your top 100 might be different than this person's top 100. And like, do you use another LLM to judge that LLM?
Yeah, the question is for the hiring example, how do I know my ranked result is great for what kind of rubric I use? Does that capture it?
Yep.
Yeah. So the traditional way of measuring the machine learning model still applies to here. To measure the recall, of course. If you have a golden step to measure the recall, you can let the model output a very structured JSON schema that you can like efficiently post process and measure the ranking. And if it's not good, everybody has the same rubric, a different rubric, of course. You could either further prompt tuning, or you could do the fine tuning and insert your golden step into the training step.
So like either way, you still need like classified trained data to be able to validate.
Only if I think the general suggestion we recommend is see how far the prompt can take you. Yeah, if you try the prompt for many times and if it still doesn't work, try fine tuning. In most of the cases in today's model, the prompt should take you really far. If it's if you give some clear instructions about candidates whose attributes are explicit in the documents.
Thank you.
Well,
Hi, my name is Walker. Thank you for the talk. I have a question more about like building a company. So you talked a lot about like foundation models have like world knowledge. They can do all these different tasks. They're generally pretty smart. Where does like the foundation model end and like the application layer and like a defensible business start?
Yeah.
Because it seems like you can toss a language model at anything and it'll perform like decently if you could prompt it well enough.
Let me know if I get your question correct. So your question is like how to build a business with the foundation models. So
Yeah, like how do you make a defensible business?
It's defensible
if someone
business.
else is doing the same thing.
Yeah. Well, the short answer is you build the application, you build the product, not building the infrastructure. Like for example, you can build it for there's an app. I'm not sure if anyone has used here, but there's an app for like students and researchers. It costs like $10 per month, and it's basically like a chatbot, But the difference is that it allows you it has preloaded all the archive research papers into like its backend, and there is also like a comment space for you to make comments about the documents. So that's non-AI feature. They're very handy to do the research about a certain domain. Well, what sets them apart with OpenAI? OpenAI does not have archive paper already built in. OpenAI's deep research costs like 15 minutes to search from the worldwide internet to find an answer. OpenAI does not have a workspace for the tag, the papers that you love, for example. They won't do this, right? So this is kind of business that you should be investing on, kind of building on vertical and more on the user experience, the business user experience to sell into. We see a lot of good successes there. There are specific apps for the rental managers, from apartment building to automatically just upload the rental agreement and get data out in a business interface. They don't understand anything about the foundational language model, and OpenAI won't step into this business. Yeah, so they stay closer with the business application, the better.
Yeah, cool. Thank you.
Yeah.
I have one comment to make for him. If your UI looks like a chatbot, you cannot compete with them. If your UI looks something very different, then you have a chance, right? So there's a workflow, there's all kinds of things around it, just asking the model, and you have to innovate in that space.
Yes, it's good. It was okay. Yeah, not sure if you've seen that, but OpenAI just in the last few weeks, they had a product announcement in Japan, in Tokyo, I think. And they're building, it seems to be like they're building a CRM. OpenAI is actually building a CRM. Can't believe this. Because they see, a lot of like outreach tools are using, automatically email someone and get the leads in, etc. OpenAI sees that this is just like why not opportunity to eat the cake. And I talked to, I came from YC, so I stay very close to our advisors, even if we have graduated. But yesterday he told me that OpenAI went to YC and basically just saying, like, so looking for use cases about like to step up into more like vertical. Like if I would build a Docker chatbot, like why OpenAI could not like abstract the layer. So I think to your point, Walker, right, that this closer you stay to the business layer, the better. That's something.
No, I was like, can you hold the mic closer?
Sorry,
I'm just couldn't hear the last part of what you said.
Any more questions?
Thank you. Oh, go ahead. Oh, yes. Sorry, Sean.
Sorry. Since you mentioned archive, actually that reminded me, either last year or the year before, you all know you will have an apprenticeship project coming up in your ML operations class next module. And one of the group build turning into the key concept of archive articles into a podcast. So each article, they turn that into a 5 minutes of podcast video. So people could listen to the concept of it instead of like reading the whole thing. So I don't know where the students are, like maybe I should track them, but so I think that would be a good opportunity for students to start thinking about an apprenticeship ideas to build upon basically what Richard had been mentioning today or what his companies do. So from that sense, I want to ask you, like you stay very close to the industry trend, and for the new graduates in data science or data engineering or AI, what is your advice for them? Like, how do they prepare for this seem to be very competitive market? What kind of skill set they should focus on, let's say, in the last 2 months of their master's program before they enter the job market?
I think keep the eye open for the startups, for the fast growing startups. Look at when you looking for a new opportunity, career opportunity. Look at all those big investors' investment from like A16Z, Lightspeed, Google Ventures, for example, and look at what they're doing. Startup. First of all, I think there are two benefits. Like one is the enterprises are not the innovator in this like AI era right now. The real innovators are startups. So I think this is going to be 10-year opportunity. So if you work at a startup, maybe it's even better than working at an enterprise to set like a 10-year run, a good 10-year run for in the future. Maybe you're a startup company based on what you've learned in one of the startups you work with that is closer to the business layer. They're solving the problems that are not efficiently, but you know a better way to solve it. So yeah, keep the eye open. Do more side projects as much as you can. Right, do more side projects. Explore the art of possibility there. Yeah, I think that would be my suggestion.
Was there any particular set of skill sets currently that you think like normally people don't get from the school's education, but it's something like they could pick up at this current stage?
Well, lots of startups are publishing tutorials about how to build a RAG chatbot, for example, different RAG strategies. My personal how do I keep up the industry trend is I follow some key people on Twitter and on YouTube. So keep updated to the podcast and to the Twitter post they made, and read through the whole thing and yeah, keep up my speed. I think to be honest, like to have a heart of just learning. I think learning is the best skills in the fast changing market. Learning is the best skill.
Could you talk a little bit about your entrepreneurial journey? Did you build a product by yourself? How do you find your co-founders? How do you find your investors? Those kind of things? Or is that hard to scope?
Anyone is interested in the entrepreneurial stuff? Anyone wants to? Oh wow, that's awesome. So if you want to build a startup, there are usually two ways to get started. I think well, first of all, I think made a good point. You gotta have the co-founder. I found my co-founder in Berkeley. We know like each other for a long time, so we have the trust. So, but for you, there might be one of your roommate. I don't know. I don't know if you live in a dorm. So, finding a co-founder, idea is not important. The reason I say that is you'll pivot a few times after this. When we got into the Y Combinator, we don't execute the same idea that we're now. So idea is not important. What's important is learning. By learning, I mean not like learning yourself. So when you really build a company, try to talk to first of all, the foundation, right? You will need to find a industry that you are interested in. Like if you're interested in financial, you should talk to the users in the financial. You should be interested in the insurance, talk to the to ones in that industry. So pick an industry, pick a swimming lane, and go talk to those people. And in a financial institutions, for example, there are hundreds of business units. Right? And then you gotta pick like which business. Do you want to pick the compliance? Do you want to pick the investment? So that's also like an exercise, and that's why it's important to. I would say, I see two kind of founders that are successful. I don't classify myself as a successful founder yet. So take it with a thought. But this pattern I see is one has worked in a large company for many years, who have accumulated enough knowledge for them to step out and solve a systematic problem in the domain that they know. The other type of founder is fresh, like college graduate, afraid of nothing. Just start working on something that people love. Take a look at Mercor, MER. I think it's called MER COR. It's a company that recently raised $100 million or something. Founder, 21 years old, graduate from, maybe dropped out or graduate from college, built a hiring platform, AI hiring platform. The people love, but that's like it's on the premise that one is you can find the pain point, and you can fearlessly execute against that pain point and listen to what you just said. So that's a second kind of to the consumer to see route. To see. Talking to investors is it's a great question. I mean, if you have for the first investment, usually if you're running a 2B SaaS app like us, you need a few like logos. Basically, a few logos is enough. Their problem, they're willing to work with you, etc. business model not quite important at the first investment. And for 2C to consumer, right? Organic usage, right? You have 10,000 users registered. Doesn't matter if you make revenue or not, right? You can always, once they are getting into the door, you can always make revenue by. There's a lot of ways to make revenue. If your app is like popular, so it's the most important metrics for 2C apps. And then you can ask for investment. I mean, usually my strategy is like, you don't ask for investment, let investment find you. Yeah. So then they will know you on the market if you're good somehow, right? If you're haven't get into one of the incubator program like Peer VC, Y Combinator, they'll find you out. Yeah. First seed stage, I won't worry too much about it. Just focus on the product and problem itself. So I'll pause here, see if there's a follow-up question.
All right, I just wanted to make sure.